Welcome back. Today we're going to cover quadratic functions and vertex form. So a little bit of the vocabulary before we get started. A quadratic function, that in here on this space, is also known as the squared function. And when we talk about squared, we're saying that the highest degree of the terms is going to be raised to the second degree. So the parent function is f of x equals x squared. The graph of a quadratic function is described as a parabola. And you may say as an adjective, it has a parabolic shape. And it's often described as a U, the letter U. It is symmetrical, has a maximum or a minimum, right? So we know that it may be opening up and have a minimum. It may be opening down and have a maximum. And all the points are equidistant from a fixed point called the vertex, which is inside the parabola, and a directrix, which is outside the parabola. And you'll get into that definition and using the vertex and directrix in pre-calculus. Okay, y equals ax squared plus bx plus c is the equation of the quadratic function in standard form. Today we're going to go over the equation in vertex form. So the vertex form of the quadratic function always has an a in the front that tells us if it's going to open up or down, and an h and a k. The hk are the coordinates for the vertex. So remember, this has to be a squared function, so there has to be a number for a. It can be positive, negative, a fraction, or an integer, but it cannot be 0. Okay, let's go to the first couple questions. We're going to review some of the topics from chapter 1. So the first example asks, how are the transformations of the graph f of x equals x squared related to the equation representing another quadratic function? So in the blue is the parent function, y equals x squared, and I'll put f of x equals x squared. Well, we know that this is a transformation. We know that it's going to be a reflection, right? So this is reflected. I'll put this as 1. It was reflected on the x-axis. Because we had a negative here. It's also going to have a vertical compression because the a is 1/2. And then the 2, that plus 2, tells us that this graph will move and be shifted 2 units to the left. Okay, now let's go over to here to the next one, where j of x is in the orange. Again, we have the blue function is our f of x. And remember, our f of x is the parent function. I'm just going to use a different color just so we can see clearly, but there's a couple things that happen. The first, there's a vertical stretch. And I could say, well, everything's being multiplied by 2, right? And then there's going to be 2 shifts. So it's going to go to the right 1 unit, and then it's going to go down 3 units. What you can see with both of these graphs is the vertex. And so here we're going to identify the vertex for each of them. And I'm just going to practice with these two. We can actually first see the vertex on this graph as -2, 0. And then over here, we can see this vertex is 1, -3. And you can see that 1 is right here and -3. Now let's consider the key features of the quadratic function. Here we're given the equation f of x equals 2 times x minus 3 quantity squared plus 4. Now remembering back from chapter 1, we can think about the transformations. So we know there's not any reflection because we don't see a negative in front of the x or in front of the parentheses. We do, however, see a stretch, so it's going to be a vertical stretch by 2. And that means that this graph will become more narrow. And you can see that with the picture here. There's also a translation. We know that this graph is going to be shifted or translate right 3 units and up 4 units. When we consider those transformations and we look at the equation in vertex form, we can identify key features or characteristics of the graph. The first part that I want to point out is the vertex. So we know that this vertex here, it's shifted 3 to the right, 4 up, so that vertex is going to be 3, 4. I'm just going to highlight it right here. So that gives us the ordered pair 3, 4 as the vertex. Now the parabola is symmetrical, and if we can imagine a line that we fold the parabola along to cut it right in half, that's called the axis of symmetry. The axis of symmetry is always a vertical line, and it's going to match the h value, the 3 in this equation. So this axis of symmetry is x equals 3. Always remember to write this as an equation, x equals a number. Now this graph does not have any x-intercepts. You can see that it's going above the x-axis right here, and it opens up so it never touches the x-axis. It will touch the y-intercepts, or have a y-intercept, but it's probably not going to be on this graph. You can see that it's already at 10 up here. Now if we wanted to find the y-intercept, we just have to plug in 0 wherever we see x. So this equation was 2 times 0 minus 3 squared plus 4. Now, -3 times -3, or -3 squared, is 9. So this would be 9 times 2. I'll write the 2 first. 2 times 9 plus 4. And then 18 plus 4 will give us 22. So the y-intercept is 0, 22. Looking at this graph, it will continue to the left and to the right. So the domain is all real numbers, -infinity to infinity. The range, however, is dictated by this 2. The a is greater than 0. So it means it's going to open up and have a minimum. The minimum, that y value, that's the lowest, actually ends up being the k, the 4. So we know that this range, it's going to go to 4 and include 4, so I write a bracket to the left, and it's going to go up in the positive direction, so it's 4 to infinity. To write the equation of the parabola, we need to be given at least 2 points on the parabola. So here we're given a point, which is the vertex. And we know the vertex has the letters H, K. And we have one more point over here, the y-intercept. And we can plug that in for our x and y. So remember, in vertex form, it's y equals a times x minus h squared plus k. Now the only variable that's missing is our a. So I'm going to substitute all the variables and solve for a. For y, I'll substitute in -1. A I don't know. For x is 0. Minus a -2, so it ends up being +2 squared. And then 3 for k. When I solve this, we'll get 4a here. I can subtract 3, so -4 equals 4a. So a will equal -1. Now to write the equation, remember it's f of x equals a times x minus h squared plus k. Now I have to make sure I have an f of x. We know our a is -1, so I'll just put a negative there. Leave in the variable x. Okay, we need to make sure we still have a variable x in the equation. Our vertex was -2, so it's minus a -2, so it ends up being +2. And our k was 3. So our equation would be f of x equals negative times x plus 2 squared plus 3. Now let's go to a word problem. So for this word problem, we have a volleyball here which is thrown in a parabolic shape, right? Just like a ball would go up in the air and then come back down. We know that the vertex of the graph is 120. And then we know that the path of the ball also includes 0, 4. So we have 2 points here so that we can solve the equation. So I'm going to write them below here. So we know that 120 is our vertex, our HK. 0, 4 is another point on the graph. So I'll write that as XY. In vertex form, the equation is y equals a times x minus h squared plus k. And I'm going to substitute all the variables. So 4, a we don't know, 0 minus 1 plus 20. When I simplify, I'll just get a right here, because -1 times -1 is just 1. And then we can subtract 20, so a equals -16. Now in vertex form, this equation, I'll use a y, equals -16 times x minus 1 squared plus 20. Now that's the equation in standard or in vertex form. Just want to be wary that this question was asking for the equation in standard form. So that means we're going to have to multiply everything out. So if we FOIL this out, you get x minus 1 squared, so that's x squared minus 2x plus 1. I'm going to distribute the -16, so it's going to be -16x squared plus 32x minus 16, and then I can add the 20. So my final answer will be -16x squared plus 32x plus 4. So we're okay with the equation in vertex form up here. I think we're good with solving for that, or we have to solve for a. But the last step to write it in standard form, well, you're going to have to FOIL everything out and distribute that. Okay, for the next example. So for this one, it says the function g is a translation of the parent function f, 1 unit left and 3 units to the right. Or sorry, 1 unit left and 3 units up. what is the equation of G? Write the equation in standard form and in vertex form. So we're going to have to write both. Okay, so key things here. There's no mention of any stretch. Okay, so we're going to have to make sure that we double check the A value. Okay, so if I look at this graph, this G function, we can see that the point 0, 4, just going to write it a little bit bigger, is also on the graph. And then you can see right here, from this little shift, one unit to the left and 3 units up, we know that the vertex will be -1, 3. So I'm going to write this up here. So -1, 3 is our vertex, our HK. We have another point on that g of x function, which is xy. When we substitute all of those variables into vertex form, we'll get 4 equals a times 0 plus 1 squared plus 3. Now when I simplify this, I'll just get a here, because 1 times 1 is 1. And then I subtract 3, and we do have that indeed a equals 1. So that's good. There is no vertical stretch or compression. So we know that the g of x, this function, will have an a equal to 1. So I'll just write, I'll start with the parenthesis. We know that the vertex was -1, so it's going to be x plus 1 squared plus our k. So this is the equation in vertex form. I'm going to put a box around it. Okay, so that's part of the answer. The next part is to write this equation in standard form. So to write this in standard form, we're going to have to FOIL out x plus 1 again times x plus 1, and then add the 3. So again, when you FOIL, get x squared plus x plus 1, and then we'll have x squared plus 2x plus 4. So g of x in standard form will be x squared plus 2x plus 4. Put a box around that as well. So in summary, the graph of the quadratic function is called a parabola. And the vertex form is y equals a times x minus h squared plus k. And that is from the parent function f of x equals x squared. Now I want to make sure we go over this. The vertex is the HK. And the axis of symmetry is the vertical line that cuts the parabola in half. So if this point is h comma k, the axis of symmetry would be a vertical line that would be almost like the fold that I could wrap the parabola around to show that it's symmetrical. And this vertical line is always x equals h, because vertical lines always start with x equals. The domain of all quadratic functions is all real numbers, negative infinity to infinity. It's really important to remember that when a parabola opens up, it's going to have a minimum at that k value. So here is the minimum, y equals k. So the range will be k and then everything above k, so k to infinity. And remember, that'll be closed. Even though this has a parenthesis, we know that would have a bracket. Another correction over here I want to make sure we go over is this one has, when a is less than 0, we know it's going to open downward. And when it opens downward, it's going to have a maximum. So we're correcting the book here. The maximum is going to also have that y value k, and the range will be k as the maximum with a bracket, and anything less than that. So the range would be negative infinity to k. Well, thanks for spending time with me. I hope this lesson was helpful.